Let's read the question. An elevator car whose floor to ceiling distance is equals to 2.7 meters starts ascending with a constant acceleration of 1.2 meter per second square. Okay, this is nothing but 2.7 meters. Okay, okay. The acceleration of the elevator is equals to 1.2 meter per second square. Okay, now okay, what happens? This is the elevator which starts rising up with this velocity. And after 2 seconds, what happens? A bolt out here starts falling freely. Okay. From the frame of reference, the acceleration of this bolt would be g plus acceleration of the elevator in opposite direction. Okay. So the bolt's free fall time would be the time taken by the bolt to cover this much distance with this acceleration. So S is equals to ut plus half A effective or acceleration into t square. But A out here is nothing but g plus 1.2. Out here S is equals to nothing but 2.7. U is nothing but 0. Why? Because from the frame of reference, this bolt has just started dropping, no? Okay. So S is equals to 0 plus half A. What's the value of A? 9.8 plus 1.2. 9.8 is the value of acceleration due to gravity, and 1.2 is the pseudo acceleration into t square, or t square is equals to 2.7 into 2 divided by 9.8 plus 1.2 is nothing but 11 under root, not under root, or t is equals to under root of 2.7 into 2 is nothing but 5.4 divided by 11, which is approximately equals to 0.7 seconds. Okay, if we solve this equation comes out to be this equation. Okay. Now the second part of the question is the displacement and the distance covered by the bolt during the free fall from the frame of reference fixed to the elevator shaft. Elevator shaft is nothing but the shaft of the elevator which is fixed to the ground. So from the frame of reference from ground. Okay. So after 2 seconds, this happened after 2 seconds, no? After 2 seconds. So after 2 seconds, if I see, suppose the ball picked up the velocity of the elevator from the frame of reference of the ground. So u is equals to, what is the velocity after 2 seconds? V is equals to u. Acha. What's the value of u? The value of u is nothing but elevator starts 0 plus a. What's the value of a? 1.t into 2, or v is equals to 2.4 meter per second. So as the, suppose this was the ground, okay, from where the elevator started. Now as the elevator moved for 2 seconds, what happened? Out here, the velocity is equals to 2.4 meter per second. Velocity is equals to 2.4 meter per second. Now what will happen when someone sees from the ground? The projectile or the bolt will start to move upward with certain velocity. Then it will start to move down with acceleration g. So acceleration g is always constant out here. Okay, this comes from the acceleration of gravity due to Earth, and this 1.2 won't be added out here. Why? Because our frame of reference is inertial frame of reference. Okay, this frame of reference doesn't have any acceleration. Okay, so out here, what is the distance covered by? Acha, without seeing the distance, let's find the displacement first. For displacement, okay, what is this much distance? Acha, this much distance is nothing but Let's see, what is this much distance? Acha. If it covered for uh 0.7, acha. One more thing. The bolt won't hit the ground. The bolt will hit the elevator shaft, no? The bolt will hit the elevator shaft. What is the total time of flight? That means when the bolt reached out here, the projectile will stop. Okay. So what is the total time of flight out here? Can I say the total time of flight is equals to 0.7 second? Okay. Acha. So I'm simply applying S is equals to ut plus half ut square. S is equals to ut plus half at square. Okay. Out here, S you have to find it out. U is nothing but 2.4. T is nothing but 0.7. And A is nothing but minus G. Okay. Why minus G? Because the acceleration of gravity I have taken upward to be positive and downward to be negative. So if upward velocity is plus 2.4, downward acceleration would be minus G. And S is nothing but we have to find out in the question. So I can simply write S is equals to 2.4 into 0.7 plus half. So this minus this minus would be multiplied by this one, and this one would be minus half G. The value of G is 9.8 and the value of T is 0.7 whole square. Okay, if I calculate this one, the value of S comes out to be minus 0.7 meters. So displacement out here, or this much displacement, is nothing but 0.7 meters. Okay. Okay. So displacement out here is 0.7 meters. The second part of the question is distance. What is the distance? Distance is nothing but total distance. Okay. How can I find how much height did it reach up? See, velocity out here is equals to 0. Can I simply say that? So can I simply say v square is equals to u square plus 2s? If I apply the formula v square plus u square, v square is equals to u square plus 2s between these 2 points. Okay, I can simply find out this height. So applying the formula, okay, let's do that in next page. Okay. Now what I'm trying to do is I'm trying to apply v square is equals to u square plus 2s for these two steps. Okay. So s is nothing but this much distance. So v square is equals to u square plus 2as. Gotcha. What's final velocity? 0. Why? At topmost point, the final velocity is equals to 0. U square is nothing but 2.4 whole square. So 0 is equals to 2.4 square plus 2 into minus 9.8 into s. Or s is equals to 2.4 whole square divided by 2 into 9.8. Okay, is equals to s. Now the total distance is nothing but s plus s, because the bolt goes up then comes down, no? So s plus 0.7. So total distance is equals to total distance is equals to 2s plus 0.7, or is equals to 2 into 2.4 square by 2 into 9.8 plus 0.7, which is equals to 1.3 meters. Okay. Okay, let's read the question. Two particles, 1 and 2, move with constant velocities v1 and v2 along two mutually perpendicular straight lines towards the intersection point O. What question is saying is, there is an intersection point O. Okay, this is there are two particles, particle 1 and particle 2. They're moving mutually perpendicular. That means this particle is moving in this direction, okay, with velocity v1, and this particle is moving towards O with velocity v2. Okay, the direction between v1 and v2, or the angle between v1 and v2, is 90 degrees, mutually perpendicular, and they're moving with in a straight line with constant velocities. Okay. At moment t is equals to 0, the particles are located at a distance L1 and L2 from point O. So at t is equals to 0, at time t is equals to 0, this distance is L1 and this distance is L2. This much we have understood. Okay. How soon will the distance between the particle be smallest? So when this is moving out here, this will be moving out here. So these may or might not collide, okay, depending on the velocity v1 and v2. Okay. How soon will the particle reach the closest position? Acha. To find that one, see, the closest position will be somewhere around here, but it is very difficult to analyze in this frame of reference. So to counteract that, what we do is we take the frame of reference of either v2 or v1. Why? Because both of these velocities are constant. Then neither the direction of these velocities is changing, neither the magnitude. So we can either take this as frame of reference or this as frame of reference. So suppose I take this body as frame of reference or particle 2 as frame of reference. So how does the problem translate into? The problem gets translated into, this is a point O, this is a particle 2, and it is observing particle 1, okay, moving with velocity v1, the velocity of the particle 1, and v2. See, this particle had v2, so when I translate this in frame of reference of 1, so this body will see this body moving with velocity v2 in this direction, okay, v2 because of relative motion. Okay, now see, this distance is L1 and this distance is L2. Okay, now with respect to this particle, how this body appear to move? This body would appear to move in this line. Okay, or a line along the vector v1 vector plus v2 vector. Okay, now see, depending upon the magnitude of v1 and v2, okay, this line might coincide at 2, might be greater than 2, but the approach will be same. See, what is the approach out here? This particle will move along this line as seen by this body, will be nearest when there is a perpendicular distance between this point and this point. So the body will be nearest. Body 1 will be nearest at 2. When out here at this position, this is 1, this is 2. Understood this one? Now how do I find out this position? So let's draw out geometry. Okay, this is a straight line connecting 2 and point 1. Okay, let's make this angle theta. Let's join this line. Let's, if this angle is theta, can I say tan theta is equals to v1 by v2? Tan theta is equals to v1 perpendicular by v2. So out here, tan theta is equals to v1 by v2. Okay. Now see this angle. If this is theta, how much is this much angle? This much is 90 minus theta. If this one is 90 minus theta, I'll always call, whenever I'm teaching physics, I'll always call 90 minus theta as theta dash and theta as theta because they are complementary to each other. Okay, so if this is theta, this is 90 minus theta, this is 90. So this again becomes theta. So this angle is again theta. Okay, so can I say this distance, this distance, okay, from point O till this point, till this point is nothing but x. So this point to be x. So can I say tan theta is equals to x by L, sorry, L1 by x. Okay, tan theta is equals to L1 divided by x. Okay. Now, if this angle is theta, can I say this angle also to be theta? So even this angle is theta. Okay. Now, problem is how much is this angle? Y. How much is y? And why do I need to find out y? I can simply say shortest distance, this distance is equals to y sine theta. Y cos theta is nothing but this one. This one is nothing but y sine theta. If you look at this triangle closely, I'm drawing or zooming out this triangle. Okay. This is 90 degree. This is the nearest distance. This is the nearest distance. And this is equals to y. This is equals to theta. So can I say nearest distance is equals to y sine theta? You need to find out the value of y sine theta. Okay, in this triangle. Okay. So this is our equation one. Okay. Okay. We do know that x plus y is equals to L2. X plus y is equals to L2. Okay. And from this equation, x is equals to L1 into V2 by V1. V2 by V1. If I'm taking this equation. When I'm taking this equation, x is equals to L1 into V2 by V1. Okay. So when I'm substituting this value of x out here, what do I get? L1 into V2 by V1 plus y is equals to L2, or y is equals to L2 minus L1 into V2 by V1. Okay. Okay. Now what else do I need to do? I need to find out the value of sine theta. This value of sine theta. Okay. So from this triangle, if tan theta is equals to V1 by V2, then I say, see, from this triangle, okay, I'm drawing this triangle tan theta is equals to outline. So suppose there is a triangle, but theta is there. Tan theta is equals to V1 by V2, or perpendicular by base is equals to V1 by V2. Okay, what is sine theta? Sine theta is nothing but perpendicular by hypotenuse, and the value of hypotenuse is V1 square plus V2 square under root. The value of hypotenuse is V1 square plus V2 square under root. Okay, so sine theta would be V1 by under root of V1 square plus V2 square. This much is understood. And we need to find the value of y sine theta. Why? Because y sine theta is the closest distance. Therefore, closest distance, closest distance is equals to y sine theta, which should be equals to L2 minus L1 into V2 by V1 into sine theta. Okay, which should be equals to, acha, I'm simplifying this equation on the next page. Acha, where sine theta is equals to V1 by under root of V1 square plus V2 square. Okay, so okay, y sine theta is equals to L2 minus L1 V2 by V1 into V1 by under root of V1 square plus V2 whole square. Now let's simplify this equation. If I multiply, if I simplify this equation, okay, this equation becomes L2 into V1, L2 into V1, and this parameter into V1. So it becomes L2 V1 minus L1 V2 divided by V1 square plus V2 square. This out here is the shortest distance. Shortest distance. Okay, let's take this question. From point A, located on a highway, one has to get by car as soon as possible to point B, located in a field at a distance L from the highway. So what is this question saying? This question is saying there is a point A and this is a highway. Okay, and there is a point B which is located at distance L from the highway. Okay, it is known that the car moves in the field n times slower than on the highway. So out here, if the velocity is v out here, okay, and on the field the velocity is v2. So we know that v1 by v2 is equals to n, or the car moves slower in the field than on the highway, or v1 is equals to n times faster than v2. This is the equation number one. Okay, now at what distance point D one must turn off from the highway? So suppose out here he has to go out here, he must turn at point D. Okay, so he goes from head to head with velocity v1 and he will go from head to head with velocity v2. See, if he turns right out here, he'll be moving a covering a shorter distance with lesser velocity, so he might take greater time. On the other hand, if he goes out here with faster velocity, then turns out here. So out here he's covering maximum time, maximum distance with faster velocity, but he's taking a larger path, no? So somewhere there must be a optimization in which he takes turn to the field. Okay, and let that optimization be at point D. So at point D, he takes a turn and move towards point B. Okay, move towards point. Let this be a straight line. Now let this entire length of the path be y and this length of the path be x. Okay. Now you have to find out at what point, at what value of x does it turn off so that the time taken is. So out here, what is the time taken out here? T1. T1 is equals to nothing but this distance divided by velocity, or this distance is nothing but y minus x. So y minus x by v1. Okay, and then this distance, what is this distance? This distance is nothing but L square plus x square under root. So under root of L square plus x square is the distance. Okay, this is the distance. So what is the time taken for T2? Time taken for T2 is nothing but distance, which is under root of L square plus x square divided by V2. So total time taken. Total time taken is equals to T1 plus T2, which is equals to y minus x by V1 plus L square plus x square divided by V2. Now from equation 1, from this equation, I can easily substitute v1 is equals to n v2, or t1 plus t2 is equals to y minus x by n v1 plus under root of l square plus x square divided by v2. After this is not v1, this is v2. Now in physics, whenever minimum or maxima is asked, one has to get by card as soon as possible. So whenever minimum or maximum is asked, just make a equation. So I made a equation of time because I need to take minimum time. Okay, and draw an equation and differentiate with respect to a variable and make it equals to 0. So what I'm essentially doing is, as soon as I'm drawing an equation of time, that means if I make a graph of this time of t1 plus t2 versus a variable on the x-axis, and when I differentiate it, the slope at maxima and at minima is equals to 0. Okay. So so we have to figure out what is the variable out here. See, y. Y is a constant out here. X. This x is a variable out here because L, V2 and N all are constant. They all are fixed in the question from before only. And one more question some of you might have. So how do we understand it is maximum or minimum? See, in physics, whenever maximum or minimum is asked, just differentiate and make it is equals to 0. In mathematics, there is another topic for maximum and minimum. For maxima and minimum. That means whenever you are drawing a graph of some function with respect to some variable. Okay, suppose I'm drawing a function of y with respect to x, of y is equals to fx. This is the function I'm drawing. So for maxima, okay, for maxima, for maxima, there are two conditions. The first condition is dy by dx is equals to 0, and the second condition is d square y by dx square is lesser than 0. So, since this is a double derivative, we do not go this far in physics. Okay, see, and the condition for minima, for minimum is also dy by dx is equals to 0, and d square y by dx square is greater than 0. So in physics, whenever maxima or minima is asked, just differentiate and make it equals to 0. You are not required in physics. The question won't come to tell either it's maximum or minimum. Okay. So when you differentiate this equation, with respect to the variable in this equation, what is the only variable out here? X. So can I say d t1 plus t2 by dx is equals to 0? It will give the minimum value of x. Okay. So how do I differentiate this term? Okay. Let's do that on the next page. So from here mathematics starts. So out here, if I differentiate this term, y minus x is nothing but minus differentiation of x is nothing but 1 by n v2. If I differentiate this term plus 1 by 2 l square plus x square into 1 by 2 minus 1 by 2 into 2x divided by v2 divided by v2. Okay, this is the differentiation of this one. This is the differentiation of this one. Okay, which is equals to 0. Okay, or out here, can I say? Can I simplify this term? Okay, v2 and v2 will get cancelled because if I take v2 common and multiply it by 0, this will get cancelled. So 1 by n plus x by under root of L square plus x square. Okay, see, I'm taking V2 common and multiplying it by 0. You can always do that in this type of equations. And 2 out here and 2 out here is cancelled. Okay, is equals to 0. Or x by under root of L square plus x square is equals to plus 1 by, minus goes to the right hand side and it becomes 1 by L. If I square both left hand side and right hand side, I get x square by L square plus x square is equals to 1 by L square. If I take the reciprocal of both left hand side and right hand side, I get L square plus x square divided by x square should be equals to n square. Now if I take L square by x square plus 1 is equals to n square, or L square by x square is equals to n square minus 1. This, let's do it first. Or x square by L square is equals to 1 by n square minus 1, or x square is equals to L square by n square minus 1, or x is equals to L by under root of n square minus 1. So the value of x should be this value. Okay. From here, this is purely mathematics. In this entire slide, we did full mathematics. There is nothing of physics out there. Let's read the question number. A point travels along an x-axis with a velocity whose projection dx is presented as a function of time. So this is a vt graph. Assuming the coordinate of the point x is equals to 0 at t is equals to 0, draw the approximate time plots for acceleration and distance covered. So we have to draw AT curve and ST curve. So the concept out here is whenever displacement is given, if we differentiate it, we get velocity. So if we differentiate with respect to time, if we differentiate velocity with respect to time, we get acceleration. Okay, and if we differentiate acceleration with respect to time, we get a jerk. The jerk is little bit outside our syllabus, but the reverse is also true. If we integrate jerk with time, we get change in acceleration. If we integrate acceleration with respect to time, okay, we get change in velocity. Similarly, if we integrate velocity with respect to time, we get change in displacement. Okay, so the first part of our question is draw the acceleration time graph. So acceleration time graph. So this is relatively simple. So out here on the y-axis it would be acceleration, in the x-axis it would be time. Okay, so from 0 to 1, the slope is constant. If the slope is constant, that means dv by dt is constant. If dv by dt is constant, that means acceleration is equals to constant. The value of acceleration out here is equals to 1 minus 0 divided by 1 minus 0, which is equals to 1 meter per second square. 1 meter per second square from t is equals to 1. So from 1 to t is equals to 3. From 1 to t is equals to 3. The velocity is fairly constant. If the velocity is constant, that means the slope is equals to 0. If slope is equals to 0, that means acceleration is equals to 0. So from here to here, the acceleration is equals to 0. From 3 to 6, the acceleration, the slope is negative out here, or the vt curve, the slope of vt curve is negative out here. So the acceleration would be negative, but how much negative? v2 minus v1 by t2 minus t1. So minus 2 minus 1 minus 3 divided by 6 minus 3, 3. So minus 3 divided by 3 is nothing but minus 1. So from 3 to 6 second, the value of acceleration is nothing but minus 1. If I trace it out here, the value of acceleration is equal to minus 1 meter per second. Meter per second square. Okay. Now from t is equals to 6 to t is equals to 7. From this value to this value. The slope is positive out here. Okay, so what is the value of the slope? v2 minus v1, 0 minus of minus 2, 2 divided by 1. So the acceleration out here is equals to 2. The acceleration out here is equals to, from 6 to 7, the value of acceleration is equals to 2. Okay, the value of acceleration out here is equals to 2 meter per second square. Okay, now we'll go to the second part of the question, that is the displacement time curve. Displacement time curve. We can simply say that dx by dt is equals to v. Okay, so what should be the slope so that the velocity occurs like this? So when I draw, okay, if I draw displacement on the y-axis and time on the x-axis, okay, so from 0 to 1 second, from 0 to 1 second, the slope is equals to constant. Okay, so somehow my graph must be something that will give a straight line slope. Okay, so what is that? That is nothing but square or quadratic graph, or somewhat the quadratic graph looks somewhat like this. Okay, so that means if we differentiate this graph, it will look like a straight line. Okay, if you want to find out the exact value, let's find out the exact value. Okay, we know that dx by dt is equals to, what is the equation of this line? The equation of this line is nothing but v is equals to t, v is equals to t, since the angle out here is equals to 45. So dx by dt, which is equals to v, is equals to t, or dx is equals to t dot dt, or x is equals to t square by 2. So the equation of this graph is nothing but t square by 2. Equation of this graph is t square by 2. So the value of x at t is equals to 1 is nothing but 1 by 2. The displacement out here is nothing but 1 by 2 meters. Okay, now let's end with this, or now let's erase this. Achha. Now from out here to out here, from this point to this point, so that means from 1 to 3, the acceleration is fairly constant. So from point number 1 to 3, the acceleration is constant. Okay, so the velocity would keep increasing at a constant rate. So the velocity for the displacement, sorry, the displacement time graph would be nothing but a straight line. Okay, displacement time graph would be a straight line. Sorry, if the velocity, I said something wrong. If the velocity is a straight line, that means displacement curve will be a slope. Okay, and the slope of this curve is nothing but the value of this slope, where dx, or the slope, is equals to this value. Okay, now how much is this value, or what is the value of this at this point? Let's see. For 3 seconds, so for 1 to 2 seconds, it traveled with acceleration 1 meter per second square. So from, you can simply write dx by dt is equals to how much? 1 irrespective, or dx is equals to dt. So you have to integrate x from half to the value of unknown x, and you have to integrate t from 1 to 3. Okay, so x minus 1 by 2 is equals to 3 minus 1, or x is equals to how much? 3 minus 1 is 2, 2 plus 1 by 2 is 5 by 2. So x out here is nothing but 5 by 2, 5 by 5 by 2 meters. So can I take this graph on the next page? So I'm taking this graph on the next page. So now from t is equals to 3 to t is equals to 6, we have an equation of dy by dx, or sorry, dv by dt is equals to some straight line. So out here, uh, acha, dv by dt is equals to the slope out here is equals to -1. Okay, so if dv by dt is equals to -1, d square x by dt square is nothing but differentiation of double differentiation of displacement is equals to -1. So if we solve this equation, dx by dt is equals to minus t plus x plus some constant. See, at t is equals to 3, at t is equals to 3, dx by dt is equals to 1, or velocity is equals to 1. So when I apply the equation -3 plus constant, so out here constant is equals to 3 plus 1, 4, or constant is equals to 4. So I get this equation as dx by dt is equals to minus t plus 4. Okay, so dx by dt is equals to minus t plus 4. Fair and fine. Now if I differentiate this again, x is equals to uh, minus t square by 2, okay, plus 40. Okay, x is equals to minus t square by 2 plus 40 plus some constant. Okay, now at t is equals to 3, at t is equals to 3, x is equals to how much? 5 by 2. We're doing indefinite integration. Okay, so if I apply these two variables out here, I get the value of constant, or 5 by 2 is equals to minus t by 2, or minus t square by 3, minus 9 by 2 plus 4 into 3. 4 into 3 is nothing but 12 plus constant. So the value of constant out here would be equals to how much? 9 by 2 plus 5 by 2 is nothing but 9 plus 5, 14. 14 by 2, 7. 7 minus 12. 7 minus 12 is nothing but minus 5. So the constant is out here is equals to minus 5. So out here I get the equation as x is equals to minus t square by 2 plus 4t minus 5. I need to find out the value of x at time t is equals to 6. So at time t is equals to 6, I input the variable of 6 out here and 6 out here. Okay, x is equals to minus 36 by 2 plus 24 minus 5, or x is equals to 36 by 2 is nothing but 18. Okay, 1 8, or minus 18 plus 24 minus 5. So 18 minus 24 is 6 minus 5 is equals to 1. Okay, 18 plus 5 is nothing but 23. Minus 23 plus 24 is equals to 1. So our graph would come somewhat parabolic at x is equals to 1. That is if x is equals to 1 at point number 6. So out here the value of x is equals to 1. Okay, see why I did downward parabolic. See, whenever the equation or whenever something attached to t square is negative, it would be downward parabolic. Why? Have you read quadratic equation in maths? How does the graph of ax square plus bx plus c look like? Or ax square plus bx? It looks like upward parabolic. And how does the graph of y is equals to minus ax square? Y is equals to minus ax square plus bx plus c look like? It looks like somewhat downward parabolic. So whenever the coefficient of a is minus, it would be downward parabolic. Whenever the coefficient of a is plus, it would be upward parabolic. So out here the coefficient of t is minus, so it would be downward parabolic, and the value of out that ends out here is equals to 1. Okay, now from this position to this position, what is the equation? I can simply say that, acha, let me again copy this entire thing to the next end page, or let us erase this one. Okay, can simply rewind and watch it. Let me erase all this calculation. Okay, so from t is equals to 6 to t is equals to 7, we get the equation dv by dt is equals to 2, okay, or the slope is equals to 2, or d square x by dt square is equals to 2. If we simply differentiate this, dx by dt would be equals to 2t plus some constant. Okay, when you put the value of t at t is equals to 6, v is equals to minus 2. So at t is equals to how much? 6, v is equals to minus 2. So I get minus 2 is equals to 12 plus constant. Okay, 6 to the 12 plus constant. Or the constant out here is equals to minus 2 minus 12 is equals to minus 14. Our constant out here is equals to minus 14. Minus 2 minus 12 minus 14. So if I rewrite the equation will be rewritten as dx by dt is equals to 2t minus 14. Okay, so this is the slope of this graph, or this is the equation of this line. Okay, now if I integrate this again, x is equals to 2t squared minus 14t plus some other constant. Okay, again we apply boundary condition at x is equals to, or at t is equals to how much? 6, x is equals to 1. How? See, at t is equals to 6, x is equals to 1. So if we apply the equation out here, okay, 1 is equals to 2 into 6 square minus 14 into 6 plus constant. Okay, or out here 2 into 6 square, or 1 is equals to 6 square is nothing but 36, 36 to the 72. So 72 minus 14, 6, 14 into 6, 6 1 is 6, 84 minus 84 plus some constant. So out here 85 minus 72. So the value of constant is 85, 84 plus 1 is nothing but 85 minus 72. 3, 1. The value of constant is 30. So if I rewrite the equation, x is equals to 2t squared minus 14t plus 30, or plus 30. Okay, so I need to find out the value of x at 7. So the value of x at 7, sorry, value of x at t is equals to 7. So x is equals to 2 into 7 squared minus 14 into 7 plus 30. Or the value of x is equals to how much? 7 7 49. 49 into 2 is nothing but 98. 98 minus 14 into 7. 14 into 7, 98. Achha, 14 into 7 is also 98. Minus 98 plus 30. So x is equals to 1 3. 1 3. So out here again the graph would be upward parabolic, but out here the curve of this graph would be steep. It would end at 30. I think I made some calculation error out here. Just check it once. 2. Okay. So So the error I made out here is 2t square by 2. When you integrate t, it is nothing but t square by 2 minus 14t plus constant. So out here 2 and 2 get cancelled. So out here at t is equals to 6, x is equals to 1. So you apply boundary condition. This 6 would get, this 2 would get cancelled. Or it not be 72, it would be 36. 36 out here. Okay. So 85 minus 36. 85 minus 36. You all understood the mistake that I made. I made an integration mistake out here. Okay, instead of writing 2t square by 2, I just wrote 2t square. Okay, so out here, let's erase this one. Okay, and erase this one. So out here, the value of 85 minus 36. 85 minus 36. It would be 9 and 49. Or the constant would be equals to 49. If I rewrite this equation, x is equals to t square minus 14t plus 49 at t is equals to 7. Okay, so out here even this graph would be a little bit not like this. So at t is equals to 7, if I input 7 out here in this equation, x is equals to 7 square minus 14 into 7 plus 49, or x is equals to 0 out here. Okay, so out here the equation will become somewhat like this. From 6 to 7, it would be downward parabolic because the coefficient is positive, and it would be, the graph would look somewhat like this. Okay, so t is equals to 7, x is equals to 0. All of you understood this one? So let's read the question. Okay, the question is saying a point travels half a circle of radius 160 centimeter during the time interval of 10 seconds. So out here, a particle traveled half a circle in 10 seconds. The radius of the circle is equals to 160 centimeter. Okay, calculate the following quantities over averaged over that time. The mean velocity. So whenever Irodov is trying to say mean velocity, he is always trying to mean speed. So if we, instead of calculating mean velocity out here, if we calculate mean speed out here, okay, we'll get the correct answer. So out here, mean speed or average speed. Mean speed is always total distance divided by total time. Total time. The total distance is nothing but out here. What is the total distance of semicircle? Pi into r, or is equals to, this is nothing but pi into 1.6. The total time is nothing but 10 seconds. So it is nothing but 1.6 pi by 10 meter per second. The second part of the question, the modulus of mean velocity vector. What Irodov is trying to say is the modulus or mean velocity or average velocity. What average velocity means is, or mean velocity. Mean velocity is nothing but total displacement. Total displacement divided by total time. Total time. What is total displacement? Total displacement is nothing but final position minus initial position. A straight line connecting final position minus initial position, which is nothing but the length of this line. And the length of this line is nothing but 2 into r, or twice of radius, which is equals to 160 into 2, or 320 centimeters, or is equals to 3.2 meters. And total time is still 10 seconds. So is equals to 3.2 divided by 10 meter per second. The third part of the question is the modulus of mean velocity vector and total acceleration. So out here, what Irodov is trying to say is mean acceleration. Mean acceleration. is equals to total change in speed, change in speed divided by total time, divided by total time. Now one more thing, in your JEE and NEET, okay, whenever they are asking of mean acceleration, instead of speed, use velocity. It's preferable use velocity. Okay, the answer key would match with velocity. Out here, the answer key is calibrated to speed because acceleration. See, between displacement and distance, we can differentiate between speed and velocity. Speed is for distance, velocity is for displacement. But rate of change of speed is also called acceleration, rate of change of velocity is also called acceleration. So out here irodov calibrated the change with respect to speed, but you all while doing it, do it with the terms of velocity. Okay, so out here, see, the concept out here would be same. The speed out here it would be 1.6 pi by 10. Okay, the speed out here would be 1.6 pi by 10. Okay, the instantaneous velocity out here would be in this direction, the instantaneous velocity out here would be in this direction. Okay, what is the change in velocity vector? See, at this point, final velocity is pointing in downward direction. So final velocity is pointing in downward direction, which is nothing but 1.6 pi by 10. The initial velocity is pointing in upward direction, and minus of upward direction is downward direction. So it is nothing but 1.6 pi by 10. So the total change in velocity, total change in velocity is nothing but addition of these two vectors, or 1.6 pi plus 1.6 pi, 2 into 1.6 pi divided by 10, or is equals to 3.2 pi divided by 10. This is the total change in speed, and total time is nothing but 10 seconds. So out here mean acceleration 3.2 pi divided by 10 into divided by 10, or is equals to 3.2 pi divided by 100. Okay, after one more thing, the instantaneous speed out here is equals to instantaneous velocity out here. The average velocity might be 3.2 divided by 10, but that doesn't correspond to instantaneous velocity out here and instantaneous velocity out here. But mean acceleration is equals to total change in speed or total change in velocity, or final velocity vector minus initial velocity vector. Understood why I'm doing speed and velocity, or why I'm relating speed and velocity to be the same? Understood? The thing I found out here is mean velocity. Mean velocity is will be in this direction. Okay, mean velocity will be a vector along this direction. Whereas mean acceleration, total change in speed, or final velocity vector minus initial velocity vector. Okay, so it would be the addition of these two vectors, which is equals to this one divided by total time. Mean is always total by total. Okay, now speed is distance by time, velocity is displacement by time, and acceleration is change in speed or change in velocity divided by time. Understood?